Hello guys, welcome to SipCode. Today you're with me, Gulero Kininda, software engineer with a little over 7 years experience. And over that time, I've mentored a number of developers. And today I'll be taking you through the Spring Boot developer series, all the way from beginner to advanced, on how you can develop enterprise grade web-based applications in Spring Boot. I hope you follow along and code with me. So let's do it. The agenda for this series includes Spring Framework, Spring Core, Spring Boot, Spring Cloud, Spring MVC, Spring Data JPA, Spring Security, as well as Spring Integration. By the end of the series, you will understand how to use all of these modules to create an enterprise-grade web-based application, and you'll be able to deploy that into an environment such as your AWS EC2. So let's get to it. For the prerequisites in this particular series, you're looking at Java fundamentals, object-oriented programming principles, your inheritance, your polymorphism, abstraction, and things like that, and also basic web application understanding on how web applications behave, or if you've used like a HTML, CSS, JavaScript, and things like that. Basic database understanding. This will be querying a database, creating a table, adding columns, inserting data into the database, retrieving data from a select, and finally some version control understanding like your Git or similar version control. As we've seen in our agenda, we'll be highlighting the distinction between Spring Core, Spring Framework, and Spring Boot. But firstly, we want to see why Spring. Spring makes programming Java quicker, easier, and safer for everybody. Spring's focus on speed, simplicity, and productivity has made it the world's most popular Java framework. So, with this statement over here, we've already established that Spring is essentially a Java framework. So, with that in mind, remember on our prerequisite for this particular series, Java Fundamentals is essential. So if you don't have Java Fundamentals yet, I'll link a video in the description down below. Please do check that out so that you understand and you have a background with Java so that it can be easier and seamless in this particular series. With that being said, let's move to our Spring Core and understand what that is. With the Spring Core technologies, we're able to therefore understand what Spring Core is. So Spring Core is the base module in the Spring ecosystem. It offers the building blocks for a Spring enterprise application. It offers key technologies such as invasion of control, aspect-oriented programming, as well as dependency injection, Spring annotation, Spring configuration, and we get to see those core technologies clearly defined in the Spring framework. So with that being said, and the understanding that Spring Core provides these key technologies to the Spring ecosystem, let's jump and see what Spring Framework is. The Spring Framework is the middle layer in the entire Spring architecture. So let's see what that is. The Spring Framework provides a comprehensive programming and configuration model for modern Java-based enterprise applications. Key to this is on any kind of deployment platform. So if you know the Java definition is you write once and deploy anyway, right? And this key on any kind of deployment platform also comes into play for a Spring Enterprise application. So with the Spring Framework, we're able to leverage the core technologies that I just mentioned, and to see this in the features level, you can see here dependency injection, events, resources, I18N, validation, data binding, type conversion, SPL, AOP. So all of these are already available from Spring Core, and we can use them to implement our application level business logic for our Spring Enterprise application. So some of the features that are already available for Spring Boot is testing, data access, Spring or web frameworks, integration, and languages. So all of these are able to give us an application level implementation dependencies that we can then use to write our business logic and implement our code without going over and above other dependencies that are external to our application being developed. So the main thing is Spring Framework tries as much as it can to give us all of these boilerplate configurations and dependencies all in one basket. So this is the power that we have with modern Java-based enterprise framework, which is Spring. With that being said, now let's see why did I say key on any kind of deployment platform, and that is Spring Boot. Spring Boot is the last piece of the puzzle in this architecture. So Spring Boot makes it easy to create standalone, production-grade Spring-based applications that you can just run. So what this means is we can actually leverage off the Spring Boot standalone capabilities such as the embedded Tomcat server or Jetty or Undertow directly. There's no need to deploy WAR files anymore. We don't need to package a deployment artifact into an external Tomcat server or an external application server. All of this is embedded within the application itself or the application artifact itself. So just to showcase this, let's quickly jump into IntelliJ. And in IntelliJ, I can show you that we have a Spring application over here. And with this application, I can just click on this run and it should just run as mentioned in the Spring IO documentation. So with this capability, it means even when I build the application to a WAR or a deployment artifact, I should just be able to run that without publishing that into an external application server because it's able with the embedded Tomcat server, such as you can see here on the logs. Tomcat started on port 8080. I should just be able to run the file without a need of an external server being set up or JRE or JVM. I can just run it on any deployment platform. So that is what is meant by this. Over and above these capabilities, we have Spring Boot provides opinionated starter dependencies to simplify our build configuration. So with the starter dependencies, we're able to then leverage off of the Spring Framework dependencies that can simplify our build configuration. We don't have to manually handle all of these. Spring can take care of those for us. Automatically configure Spring and third-party libraries wherever possible. So whatever libraries, whether Spring or external, that we need, we're able to then leverage out of the modern configuration that Spring uses, and provide production-ready features such as metrics, health checks, and externalized configuration. So even if we're looking for application metrics or health checks, Spring Boot is able to provide that for us, such as the actuator, which gives us the state of the application, whether it's up or down, if there's any issues, and also we can be able to do some health checks via that. So the last one is absolutely no code generation and no requirement for XML configuration. So unlike legacy Java, where XML was the way to configure any bean that you would require, in Spring there is no need for an XML configuration. You can depend entirely on Spring annotations and Spring beans to configure the dependencies that you need. So with that in mind, I hope you're able to get the proper definitions and distinction between the three as simple as it can be. Spring Core, Spring Framework, Spring Boot. See you just now on the next episode. For now, like and subscribe.